Hey guys, Rudi back with another CSSE1001 and 7030 tutorial solution video. This week we're going to be looking at week 5, which despite its title, Classes and Objects, has absolutely nothing to do with classes or objects. I'm not sure why it's called that. We should probably fix that up. This week we're going to be looking at, firstly, we're going to be looking at a whole bunch of debugging. Okay, so debugging is probably one of the most important skills for any good programmer to really have. Because as the more and more you'll realize as you go through first year and onwards is that you get it right first time, maybe about 3% of the time, right? And the rest of it is debugging, figuring out where you've gone wrong, why you've gone wrong, how you've gone wrong. Basically, it's always wrong. You should always be incredibly suspicious if stuff works first time, because you've probably missed something. Okay, so we're just going to be getting straight into it, right? With this program here, you can either download it from week 5 Pi, or I'm just going to copy paste it out of here. Okay, let's have a bit of a read here. Is prime returns true if and only if n is prime. What's it say? Integer value to be tested. True or false if n is prime. Okay, cool. So this function supposedly works if it gives us back a prime number. Get primes, return a list of the first n primes. Okay. And then we are getting input, how many primes, and we're printing the first n primes. And it's supposed to do something like this. So if we put how many primes, we say 7, it should give us a list of 7 primes. Okay? Now, unfortunately, all of our tutors are noobs, and we've screwed this up somehow. So it's up to us to fix it, and we're going to go through and do a bit of debugging. Okay? So I guess first things first, let's just run it. Let's just see what goes wrong. How many primes? 7. Optimistic. Here we go. First time. And error message. Okay, there we go. Okay, so some stuff you'll start to notice about the error messages the more and more you read them, right? They're actually quite descriptive. So for instance here, file something or other, whatever, line 41 in our file. And then it's actually listed the line itself that went wrong. Okay, now if you didn't know this about idle already, in this bottom right corner here, I can't actually make it any bigger, but it shows you the line and the column that your cursor is on. Okay, so if we want to go to line 41, looks like it's this line, yep. And that's the line it's got here. And it's saying can't convert int object to string implicitly. Okay, so essentially something's an int, it should be a string, and Python's basically, it's not having a bar of it. Okay, so if we look down here, well, we know that if we print stuff on different sides as different arguments, Python's pretty happy to stick it together for us. But when we're using the plus sign, right, if we try and add if we try and add a string to a number, Python doesn't like that. And we can see that that's the same error message we're getting here. So it doesn't like the fact that this n guy is an integer. Okay, so, well, we need to convert that guy to a string in order to concatenate it with our sentence here. So I suppose we could either do this and instead use the prints, the prints nice commas, okay, in order to get that spacing, or we could do the plus sign with the spaces, right? So I can convert this into a stir, and I need to make sure I put some pluses in here so that it actually looks kind of nice. Okay, so those are the two options. I'm kind of lazy, so I prefer the string comma thing, like this. Okay, and then we just keep working through, and let's run this again. How many primes? Oh, whoops, notification. I guess I'll edit that out. 7. Name primes is not defined. Okay, cool. We're getting a different error message. Okay, don't be disheartened by different error messages. Different error messages really are it's just different forms of progress, right? As long as we're getting a new error message each time, we are working our way forward. Okay, so let's have a look. Name primes is not defined. Again, line 41. Okay, well, primes is not defined. And we've only got 2 lines here, and we can quite clearly see that there's no line that's assigning primes to be something, you know? So this primes here doesn't actually belong to anyone, right? I mean, we can scroll up and we can see we've got these functions here, right? But the variables inside the functions, they're known as what's local variables, right? So they don't actually exist outside the function. So what I imagine the bug here is that someone is assuming that just because we've done something else, we have a primes variable, but we in fact don't have a primes variable. So let's go back to our example here and see what it should be. So it should be the first n primes are, and then it should be a list of primes. Okay? Well, we had a function that presumably did that. Get primes returns a list of the first n primes. Okay, so our primes guy should probably be that list of primes. Okay, so we're going to get primes, and then we need to give it the number of prime numbers defined. Well, that's supposed to be this n guy here, so I guess our primes guy now is just going to be get primes of n, and that should, in theory, give us the list of the first n primes. Okay, and this should actually be returning a list of n primes. Just fix that up. Okay, cool. So let's keep going. How many primes? 7. And okay, here we've got something different happening. Now, we haven't thrown an error message, but you would have noticed that these 3 carets, whatever they're called, the greater than symbols, haven't actually come back in here, right? Like the cursor's just blinking and waiting. And what you'll actually learn, and if you start to see this more, is that this actually means that our program is still running, right? Because it hasn't terminated, it hasn't given us the arrows back, it's still running. And since this is a fairly brief program, that probably means we're stuck in a loop somewhere. Somewhere we've got an infinite loop that we're not breaking. Okay, so to actually stop your program running, there is one keyboard shortcut you can use, which is Control-C. And that's a keyboard interrupt, so that stops our program. See, the carets have come back. Okay, and that means our program stopped running. And if we have a bit of a look here, we can see where our program was when we interrupted it. So keyboard interrupt, and then while line 35, while len less than this. Okay, so we were on this line here, line 35, and this is indeed a loop. So it looks like we were definitely getting stuck inside this loop. Just to have a bit of a look at our other code. The only other loop we've got here is a for loop. Now, for loops, since we're for looping over something with a defined range, we can't really get stuck in that, right? Like, it sort of just counts all of them, and then when it gets to the end, it stops. But something like this, which always asks a question in a while loop, could in fact get stuck, right? If the question is always yes, sorry, if the answer to the question is always yes, then the loop is always going to run, right? And I suspect that's what's happening here. So, well, I guess this is the part where we probably get a bit stuck, right? We think, well, our loop's running forever, right? But, you know, the length of the primes should probably be getting bigger or something, right? We don't really know what to do. And so this is the easiest thing in the world to do in terms of debugging. The most basic thing you can do is just print stuff. Just, if you're ever confused, just print shit everywhere and see what's happening, right? Because otherwise we don't know what's happening inside this function. So what have we got here? We've got a primes guy. Well, I suppose let's print primes, right? Let's start off, because our question here is just saying that primes is always less than n, right? That's what we're kind of assuming if our loop's running forever. So let's actually see what's happening to primes. Okay, I'm just going to run this. How many primes? 7. Whoa, okay, now you can see that my scroll bar is actually going nuts. I'm going to interrupt this. Right? My scroll bar's gone nuts. I've printed a whole bunch of lines, and there's nothing on the line. Okay, so this primes guy is actually empty at this point, right? Our primes is printing out a blank string, and since we're printing, we're always putting a new line in, right? So I've just got a million blank lines. Okay, so it's definitely confirmed that primes is not increasing. Okay? And if primes is not increasing, then we're never going to get out of this loop, right? Because if len of primes is always 0, right? If our loop is if the length of our word is 0, then we're never going to get out of this loop, because 0 is always going to be less than 7, right? Which is what I was using for my n. So, you know, we're sort of diagnosing, we're starting to realize what's happening here. But let's just think a bit more carefully about why it would be happening. So what should happen here? If is prime I, okay, and I started at 2, primes.append I plus equals 1. Okay, so if is prime, now remember, is prime is supposed to return true if and only if n is a prime. So if 2 is prime, come down into here, append I plus equals 1. Now, 2 is a prime number, right? In theory, remembering a prime number is just any number with 2 factors. So 2 and 1, or it's always a number in itself for the 2 factors. Sorry, a number, itself and a 1, I should say. But it has to be 2 factors, so that's why we start at 2, because 1 isn't a prime number, right? So that looks all good. But basically, if 2 is prime, and we should be coming into here, but it doesn't look like we are, right? So let's actually just come over here, and let's just try running our isPrime function on 2. Okay, and if I try printing that, none. Well, that's a bit weird, right? So it definitely doesn't look like our isPrime function is doing what it's supposed to be doing at all. Returns true if and only if n is prime. Okay? So that's definitely not working. And so this part, we start to think, well, how can the getPrimes algorithm possibly work if the isPrime function itself isn't working, right? You need to sort of trace these things back up to their roots. And this is why we always encourage you guys to sort of section your code up into functions, right? Because if we get an individual function working, then that's an entire piece of the puzzle that we've solved, and we don't have to worry about that bit of code down the line, right? So see here, if we get the isPrime function working, then we know that getPrimes only has these small lines to worry about, and we don't have to worry about the whole concept of a big prime number being wrong. But I guess now we can sort of turn ahead and kind of look towards the isPrime function, and let's see what's happening here. For I in range 2, check if I is a factor of n. If n mod I equals 0, okay, so remember that this basically means if n is divisible by I, return false, otherwise return true. Okay, so for starters, I can see one small problem here, right? And if we think about this, we've got to return false here, and we've got to return true here. But when I chucked isPrime 2, we actually got a none back. Okay, now that means we're not hitting either of these statements. And if we look up at for I in range, we're going from I in range 2 to 2. Okay, and for anyone who hasn't, who doesn't remember from the previous week's, range goes from the number, the first number, up until, but not including the end number. Okay, so if we try and put in a 2 here, and we go from range 2 to 2, that actually doesn't run a single time, because we go from 2 up and 2 but not including 2, and that's just nothing. There are no numbers that sort of satisfy that criteria. So none of this code is actually going to run if we go isPrime 2, right? And that's why we get nothing back. Okay, if we go isPrime 3, for instance, we are going to get a true or a false back, right? Because we're going to go into this loop. So straight up, that means we should probably have something wrong with our flow logic in terms of when we're returning, okay? So let's think about this a bit more. If n is divisible by I, so keeping in mind we're looping from all the numbers from 2 up until the number itself, and we say, well, if it's divisible by that number, return false. Okay, well that makes sense, right? Because if our number is divisible by 2, or 4, or 5, or 6, or anything else, right? If it's divisible by one of those numbers, then it's not a prime number, right? It's automatically a composite number. Because if it's divisible by any of those, it must have more than 2 factors. Okay? But conversely, let's just think about this guy a bit more. If n is not divisible by I, right? So say n was not divisible by 3, does that instantly mean it is a prime number? Now this is where I'm not so sure, right? Because let's think about this. How many numbers do we have to check, right, before we can definitively say that the number was prime? Right? Like if I'm checking the number, you know, 5,879, right? If just because I've checked the number 3, right? Like just because I've said that, you know, this mod 3 ended up being 2, right? So we're like, oh, cool, it's not divisible by 3. Does that instantly mean I can return true? Like, no, of course it doesn't, right? We haven't checked 4 or 5 or 169 or, you know, 3,000, right? We haven't checked any of those numbers. And so we can't possibly say that it's true this early in the algorithm, right? We need to make sure that we've checked all the numbers up until this point before we can return true. So this is definitely wrong, right? And even if you sort of look at this loop here a bit more carefully, you can see that on the first time through the loop, right? So the moment we set I to be 2, let's just say that our n was, you know, 10 or 20 or whatever, right? But the first time through our loop, I is going to be 2. And then what's going to happen? We're going to return false or true straight away. We don't really have a loop here. We're looking at one number and then going true or false. Yeah, we're done. And so well, that's just not right? Because we're basically ignoring the entirety of this loop here. And so this is a common incorrect pattern you'll see when you're first starting out, right? But one of these guys can't stay within the loop, because otherwise we just have this constant return and we're not looping. Now we've already established that if we find one number that's divisible, the number's definitely not a prime number, right? So this is fine. It's this guy down here that's our culprit, okay? So let's delete this for a second. So if the number is not divisible, sorry, if the number is divisible, we return false, and we can only return true once we've checked every single number, right? So out here, we need to do something along the lines of return true. And so let's think about this. If we've checked every single number and none of them failed this check, right, then that means our number's not divisible by any of those numbers, okay? Or in other words, it must actually be a prime number, because if I've got my number n and I check if it's divisible by 2, 3, 4, 5, 6, 7, I check all of those and none of those give me a return false here, then that means it must be a prime number because we checked every single number. Okay, so let's try checking this guy again. I'm just going to exit out of this function quickly using that interrupt. That's something else you can use. And let's just purely check the isPrime guy. IsPrime true, true, false, false. Okay, so it looks like it's working a lot better now. So that's something you've got to be careful of, right? If you ever have a loop and just a straight if-else return inside there, you've probably got something wrong because you're not really looping. Okay, so let's actually go back down here and get back to going on with our program. Let's see if we can get a different error message. How many primes? 7. And what do we do? We see that we've stopped our permanent loop by fixing that isPrime, and now we've actually got an error. Line 35 in get primes, prime.append I. String object has no attribute append. Okay, well let's see here. Primes is an empty string, and indeed a string does not have an append method, right? But if we look at this, we're supposed to be using a list of the first n prime numbers, and append is something that you use to stick something on the end of a list. So I really don't know why this guy's a string. This should definitely be an empty list, right? We're going to start off with an empty list, we're going to add them all as we go. Okay, so that should fix that one up. Let's keep going. How many primes? 7. And we're hanging again, right? We've got our infinite loop back. So, you know, sometimes you make progress, sometimes the errors come back. Okay, so let's just interrupt that. And indeed, we're still stuck inside that while loop. Okay, just remember, Control C to do that interrupt trick. So let's look back over here. While len primes less than n, and we're still looping in here. So what's supposed to happen if isPrime I? We're supposed to come in here, append something to primes, and get bigger. Well, I'm just going to use that same trick I used last time. Let's print out primes. Let's see what's happening inside our function. How many primes? 7. And it's a whole bunch of 2 3s. Okay, so here we go. Print primes. So if isPrime 2, we are going to append 2 and increase I to 3. Okay, so that's where that 2 came from. I'm guessing if we go back to the start of this run, we'll have just a 2 in a list somewhere. Yep, see we started blank, then we added a 2, then we added the 3, okay? So we then came through and went if isPrime 3, 3 is indeed prime. Primes.appended 3, we went up to 4, and then we're going if isPrime 4, okay? I'm actually going to print, I'm going to print I here as well, so we can get a bit more of a feel for what's happening. Okay, so I is stuck at 4. So let's see what happens here. If isPrime 4, or 4 is not prime, right? So we're going to fall out the bottom here. We're in our sort of pseudo else, right? But we don't have an else, so nothing's actually happening in the else. So I guess it's just going to loop back here, right? And I is still going to be 4. All right, we're going to come back down. It's going to go if isPrime 4. 4 is still not going to be prime, right? And we're constantly hitting this no man's land here, right? And it's going to just keep looping, and it's going to keep looping forever because we're never changing I. Now, no, regardless of whether we check, regardless of whether the number we check is prime or not, right? We always want to move on to the next number. So this I plus equals 1 definitely shouldn't be inside this if block, right? Just because the number is prime, just because the number is not prime, we still want to move and check on the next number, right? Because we, you know, if the number is 3 and it's prime, cool, we want to move on to the next number. But if the number is 4 and it's not prime, well, that's fine too. We still want to move on to the next number 5 and keep searching that way. Okay, so let's just run that again. How many primes? 7. Ooh, okay, sweet. So it looked like it kept going all the way down. And at the end there, we had an I of 17, and we've printed 1, 2, 3, 4. We've printed 6 numbers there. Okay, I'm actually going to get rid of this print statement now. and let's just re-examine what's happening. First 7 prime nums are none. Okay, now the none error, right? Let's move this back a bit. So what did we have? That means our primes guy is none, right? Because it's the first 7 primes are none. So primes is none there. We can just confirm that. Yep, primes is definitely none. See, we got nothing back. If you want to confirm, you can do that. Cool. So primes, we assigned it to get primes, right? And that means it's going to be whatever get primes returns. And if we look inside here, indeed, we are actually, we don't have a return, right? We've got no return there. This is a really common error. Sometimes you'll see it when you're printing instead of returning, right? But if we don't return anything, we are like sort of by default returning none. So this guy's supposed to return the list of the first n primes. That's our primes guy there. Let's just return that. And let's try this one more time. How many primes? 7. First 7 primes are 2, 3, 5, 7, 11, 13, 17. And I think that's actually exactly what our output was there. Okay? So it looks like we've done. Looks like we've solved that one. Okay? So this is the sort of process you should have when you're debugging, right? You should run through first, get rid of any of those red errors, right? Just keep fixing them up, reading the specific line numbers when something goes wrong. Seeing what the actual bit of code is, reading the error message. Sometimes they're pretty helpful, you know, tells you if you've got a mismatching string and an integer, stuff like that. And then from there we have to work out the logical kinks, right? And the only way you can do that is by testing, right? So when I tried calling like is prime 2, you know, and we got nothing back, well, that's just straight away. We know that there's a problem in our is prime function, right? And so we need to break it down. We need to try is prime with several examples. See if we can try and get a feel for the problem, and if not, then we're going to have to go back and just read through the code to try and figure out exactly where the problem is if we can't get any hints from this 2, 3, or 4. Okay? Other than that, it mostly just comes with practice, and the more comfortable you get coding in Python, the better you'll be at spotting the errors. Okay, so I'm actually going to call this for part 1 for the moment, because this is fairly separate to the next section, which is all about using functions and files. So that's been the debugging part of the tute, and if you guys want to hang around, I'll leave a description for part 2. I'll leave a link for part 2 in the description probably, and I will see you guys for part 2 in a sec.